Welcome to Ask and Learn.
So in this problem, it's really almost well, it's kind of almost by definition here. It's a very simple problem. We'll talk about the answer though. So what they want is a relationship. Let's see, what exactly did they say here? Obtain a relationship for the second law efficiency of a heat engine that receives QH from some high temperature reservoir that's at TH, and I probably should note that here. This is TH and this is TL. And it rejects heat to a low temperature reservoir, and we get workout. And so this is some kind of heat engine here. Um, and again, the internal workings of this we don't care about. We just basically look at it as a black box: heat going in, heat going out, work coming out. Now, for the second law of efficiency is the ratio of the the ratio of the availability or the exergy recovered to the availability supplied during the process. So we can see that's basically the exergy recovered divided by the exergy expended. Okay. So we have what was recovered here is the work that we got out. All right. So that's, well, I guess I didn't call it W out up here. I should maybe call this out just to be clear. So the work that we got out, that's what we recovered. What we expended was this basically, the heat, these types of terms here, right? And again, you can think about this as kind of Q, like this term here. You can think about it as QH times T naught all over all times 1 over T naught minus 1 over TH. All right, so that's kind of like the entropy from going from the dead state into this and then coming out of here. So when we multiply through by T naught, we get this like term here. And then likewise for here, for where we reject the heat to the cold reservoir. So we expanded that much. And so just the ratio here is, I mean, this is the second law of efficiency. So really what we can say is once we know these high and low temperatures, and we know the surrounding temperature, and we know the heat transfer, and we know the workout, we can get this efficiency. And in fact, we could even make this simpler, right? Because if we have a second law here, we know that, we have just this flow, the relationship between these things, there's a relationship between these things because conservation of energy. So actually, once we know this and this, we then know, well, once we know this and this, we then know this. So again, really all we need to know is, the high temperature reservoir, the temperature of the the temperature of the hot reservoir and the temperature of the cold reservoir, and then the heat transfer. And that will give us our second law efficiency. So again, you can say that this is the availability of the heat supplied to the heat engine, and this is the availability of the heat rejected. So that's kind of what we lost. That's what was expended during the process, the difference.